Huffman coding. Huffman coding is a data compression algorithm. Modern computer uses bytes for encoding, in which 1 byte is equal to 8 bits. For example, to encode the text happy space happy, using regular coding, you have each letter represented by 8 bits, and you end up having 11, because there are 11 letters here, if you count space, times 8, which is encoded by 88 bits. Huffman coding, in contrast, tries to achieve compression by assigning variable length code, in which the most frequently appearing letters is assigned to the shortest code. In this case, P appears 4 times in this text and is assigned to the shortest code, 0. And using this Huffman coding, you can encode the text here with just 32 bits. Now, Huffman coding is a variable length code. Rather than having a fixed length at a time, like regular coding, it has a different length, right? Which actually is a problem for the computer, because with regular coding, the computer only needs to encode consistently. They read 8 bits at a time. But with Huffman coding, you need a way to tell the computer whether it should read 1 bit, 2 bits, or 3 bits, or even more at a time. Because of that, you need what we call a prefix rule. The prefix rule is to make sure that all letters are uniquely decodable, right? In which no code should be the prefix of any other codes. I'll explain it. For example, if P is encoded by 0, no other codes should have a prefix with 0. In other words, no other codes should start with a 0. So when a computer reads a 0, it knows that it should decode a P and then go on to read the next bit as a new letter. If the next bit is a 1, you can see that there is no other codes, it's 1 alone. So it reads the next bit again, 1, 0. Again, no letters is decoded by 1, 0. So the computer will read the next bit again, which is 100, and then it will decode it as a space. So the prefix rule is very important here. Now, Huffman coding belongs to statistical encoding, in which the higher frequency letter, in this case P, gets a shorter code. As I explained before, this can assure we can optimally compress the data. Now, how do you get the Huffman codes? Is by building a Huffman tree. To build a Huffman tree, for example, we try to decode the text happy space happy, right? You will first make a table with the symbols or letters and the count, right? And then you sort them in ascending order, and you combine the two symbols with the least counts into a branch. A has a count of 2, space has a count of 1, and you combine them together, you have A plus space with a count of 3. And then this becomes a new row in the table. You have A plus space, and then you repeat it again. You combine two of the least symbols, H and Y. You have H plus Y equal to 4. And you repeat this again, and you keep building the tree until you get all the symbols together with the count of 11, which is the length of the text that you are trying to decode. And from this point onwards, things is very straightforward. All you have to do is to assign 1 to all the left branch and 0 to all the right branches. And then you find the position or the box with a single letter. P will be decoded by 0 because it takes only 0 to reach from the top to P. And space will be decoded by 1, 0, 0, A decoded by 1, 0, 1, so on and so forth, and you will get your Huffman code for decoding. Thank you.